Hello, everyone. Good afternoon if you're in Brazil. Good morning or good evening for other places around the world. It's a nice thing about having these virtual conferences. How far can you reach? So halfway through the conference now, just in the afternoon of the second day, we're now starting the session 12, Technical Challenges for Offshore Pipelines. I'm Daniel Caneiro, engineering manager at Wood, and also chair of the technical committee of the conference. And in the session now we have 4 presenters, so 3 presentations with one being split between 2 people, and we tried to bring these technical challenges from different geographies around the world. So we will start with Fábio Magalhães from Petrobras presenting on technical challenges from the pre-salt area in Brazil. We'll then go to Craig Nicol from Net Zero Technology Center presenting decommissioning challenges from the North Sea. And then we'll move to Guillaume and Florence from Total Energies, who will be presenting on challenges from West Africa. So I hope you enjoyed the session. Each presenter will be given about 15 minutes to present, and we hope to have many questions to respond at the end. So without taking much time, I'll start introducing Fábio. So Fábio Magalhães Ferreira is a mechanical engineer, graduated 2003 from Cefet in Rio de Janeiro, with a master's degree from our Military Engineering Institute in Rio as well, and post-graduation in floating systems from COPI in our Federal University. He's worked before in companies such as Eletronuclear, Nuclep, and Transpetro before joining Petrobras in 2008, and since then been working with subsea engineering in basic design of rigid risers. He's coordinated the feasibility study for this titanium stress joints for Petrobras pre-salt projects in performing global analysis of rigid risers for several projects. So Fábio, if you could please start your presentation. Welcome to our session.
Okay. Okay, I think now you can see my presentation. So thank you, Daniel, and thank you our audience for this section. I would like to present here a new technology that we in Petrobras have developed to replace flexible riser in pre-salt for a new rigid riser terminated with a titanium string on the top. This is due to the failure that we have experienced of SCCO2 since 2017, and we had to plan some measure to overcome this situation and mitigating immediate and future losses. Both on the flexible riser itself, we developed some tests to check the integrity, new inspection means and techniques to reduce the risk for a catastrophic event to occur. We developed some new designs of the flexible risers that we called mitigated pipe, incorporate some feature to improve the survivability of them, and also new concepts of and material that are based on composite pipes. But all these situations are not definitive situation to overcome this problem, or it's not really available nowadays. And so in parallel, we start using more extensively the rigid riser technologies that are inherently immune to this phenomenon, the failure phenomenon. And also we have been taking actions to reduce the cost and the schedule time for the rigid projects with a standardization, pre-qualification of long lead items. And for the replacement of lines, now flexible lines with problem, we developed this new concept that we are calling titanium pulling tube, or TIPT that we call. This technology is based on the straight jointed titanium straight joint technology that we have several of them already installed since the 90s on the world. Several aspects of this technology is based on our experience with the very flexible risers design in terms of interface with the platform, the balcony and the support interface and the top hang-off interface, and some testing for the material and the coating of the flexible risers. But also we carry out some extensive feasibility study on the TIPT technology inside Petrobras, with several testing and studies and simulation, computer simulation to be sure of some outstanding points related to this technology. We have a interaction with the market, both supplier of titanium, straight joints, and also installer, to bring their valuable suggestion and experience to our design. And all of this we consolidated in a technical specification that we put all the results of the study on design, fabrication, and inspections, monitoring that we had learned of this previous year. And also, this is a patented technology from Petrobras. That doesn't mean that we will prohibit it, on the contrary, just to safeguard our intention to continue using this technology. And what is the TIPT? Is a top section of the rigid riser that is made of titanium. We have the TIPT, titanium string here, that is welded on the rigid riser that we know the previous projects. And we have here two straight joints that we call the lower and the upper straight joint. The lower one is necessary to resist the dynamic movement of the platform here on the bottom part, and the upper straight joint used to resist the permanent bending of the TIPT in the passage on the support, completed with titanium pipe section connected with flange. And both terminations are made of carbon steel pieces that are internally cladded for resist the fluid contaminant, and also the interface based on flexible riser technology. The idea is not to have a modification on the support and the platform anyway. And the advantage that we have, the definitive solution immune to SSCO2 phenomenon, like the rigid riser with CRA, corrosion resistant alloy inside, and the titanium itself is resistant. This technology does not require the production or injection stops to perform the integrity tests that we gain time. We don't need this. They reduce the risk of failure on the annulus fluid, because don't have this problem also, this configuration also. This is for new project. the technology don't require modification on the platform, the support and the pooling system compared with a full flexible design. So it is interchangeable with flexible project and rigid by using type ET on the top connection. Also eliminate cost with the riser chain when the flexible riser don't support the load and are seriously damaged, and compatible with platform prepared only for flexible risers. The support, then no spool hard pipe here, no auxiliary system also. It's not needed for flexible riser and not even for type ET riser also, rigid riser. But we have some outstanding technical issues that we have to address, and we did that. Here the list of the inner diameter up to 8 inch. That doesn't mean that we could reach more, but the more we increase the diameter, the more the stiffness of the titanium piece stay and induce more loads on the support. And there is some problem that we don't have to reach much more than 8 inch inside in a diameter. For gas injection oil and oil production lines that are the target of this technology, main use, we have some contaminants beside the CO2, the sulfate content, and the high temperature that lead to use the more resistant titanium grades for overcome to resist for these conditions. And also the use on highly dynamic floating units, the FPSO, that the use of stress joint is normally on more static, let's say, units like SPAR, TLP, even semi, but not normally on FPSO, that we had to address this question on the loads and fatigue issues on the top of the riser and the support. The load limit of the support itself that was originally designed for flexible riser, and now we are installed a rigid riser at the titanium part that is not as rigid as steel pipe, but is of course stiffer than flexible riser and has to resist the support has to resist this loading of this element there. The coat integrity of the type ET on the passenger of the support and also on the operation, the continual operation for 30 years of service life had to be checked. And the periodic acidification of the reservoir that we use inorganic acid is stronger, like chloridic acid, and the compatibility of the metal has to be checked, and it was. But also we made several evaluation on riser global analysis, the configuration of the projects that we proposed, configuration that is suitable for the field and staggered riser to minimize the risk of interference, use the optimization software to reach on some configuration and also the stress joint dimension. We performed the stream load, combined loads and analysis also with several cases, accidental, extreme operational cases, address fatigue analysis of the rise. Here, figure of the top of the rise of the type ET string, that we made a detailed fatigue on this part to be sure. And also the pulling analysis, when the type ET bending during the passenger here, and we need to check the the utilization for this scenario, this situation. Also, the components of the type ET, we had the compact flange, that is a flange designed for dynamic use. There are standard, ISO standards that has the sizing of this flange, but we had to check also to be sure that it is feasible. The pressure contact on the coating of the type ET, to have an idea of the loading level here, to study the suitable coating material. We made also ECA on several sections of the type ET to study the possibility of using welds there, and also the pull-through, that we analyzed the final stage of the decoupling of the type ET, the upper stride joint, when we have our overload here during the alignment, and also an increase of the pressure here. It was checked also. And on the FPSO side, as the FPSO that we are intended to use type ET were prepared for flexible riser, we also checked the balcony structure, the structure itself for each of the balcony of the FPSO intended for the projects, and also the support structure, the bell mouth of the support is checked for structure, the strength, and the fatigue also. And all this result in a specification that I listed here, the main requirement that we have there, that we use an alloy that is grade 29, resistance to sulfide content and strong inorganic acids also. We specify also unwelded stride joints due to the high dynamic movement. It's a hard time to inspect it from UT during fabrication, that we limit the length of the stride joint for this reason, and the minimal yield strength to overcome the loads that the type ET is submitted to. And also the coating, we specify the wear testing, tribometer polymer pair, and also the full scale test to ensure the feasibility of the coating.
Fabio, you have 1 minute to finish, please, if you could speed up.
Okay, thank you, Daniel. Also some optimization that are being thought and will be specified in the next project. The use of titanium pipe welded on the static sections, or steel pipes here. We're reducing the number of flanges and the cost and lead time for this equipment. We have already contracted one project that is to be work fulfilled with 5 platform and 11 risers or 11 type ET. Also, it is on the way already. Some other replacement or complementary projects are also on the way in basic design. And we have also that studying the applicability for new projects, weighting risk and gains of this technology for new projects. So on the conclusion, we can conclude that the excellent SCCO2 resistance for this technology to replace the flexible riser. It's suitable for installation in FPSO originally designed for flexible riser. The studies all showed this. Increase the safety of the operation because of eliminate the risk of the failure of the flexible. And producing injection loss during integrity test. All the outstanding issue that I addressed, that I said were addressed through study qualification, and was also always included in the specification. and we have this expected optimization that we will specify on next version of the specification that is expected to reduce costs. And this first titanium project, as I called, is already bidded and order to come. So that's it. Thank you for your attention.
Thank you, Fabio. So I think I didn't mention that, but I think we'll go through all 3 presentations and have all the questions at the end. So thank you very much, Fabio. And now introduce Craig Nichol. Craig is project manager at Net Zero Technology Center with almost 20 years industry experience. Craig has a strong background in EPC, oil service companies, and project management roles, including engineering technical lead role with Aker Solutions on the CNR Murchison decommissioning contract. Sorry for that. And he's got a vocal passion for innovation and knowledge sharing within the decommissioning community. So his current role in NZTC includes ownership of all late life and decommissioning activities across the center's programs. Craig, over to you.
Thanks very much. Thanks, Daniel. I'll just share screen. And if I can just get a thumbs up that that's all working, or a confirmation that you can see, that's great. Okay. Brilliant opening paper from Fabio. I have to admit mine's going to be a little less technical and a little bit more of an oversight. So here goes. But thanks, Fabio. That was really interesting. So firstly, we need to get the slides to work. Apologies. Yes, here we are. So firstly, a quick introduction to what the Net Zero Technology Centre does. So we're based here in Aberdeen, in Scotland. We opened back in 2017, so as the Oil and Gas Technology Centre, the OGTC, if you might have heard of us in a few different guises that we've had, but we have since changed our name to the Net Zero Technology Centre, or NZTC, following in line with our passion and our aim within the industry. So effectively, we try and do it in 3 separate topics. So we, enabling, accelerating and inspiring the development and deployment of new technologies for an affordable net zero. So net zero has been spoken about massively globally at the moment, and there's a massive push, certainly within the UKCS, to drive down the carbon footprint left by the energy sector and to reach that net zero aspirations that we have by around 2040. So that is why the NZTC exists. We're broken down into 3 main categories. So emissions reduction, affordable integrated energy systems, and offshore energy 4.0, very digitalized and automation, etc. My team for late life asset integrity and decommissioning activities sits within the emissions reduction. So we will focus on that today. This is it shown in a slightly different format. This breaks down that late life and decommissioning, as well as production operations and logistics, etc., sits within the emissions reduction team. So today it's pipelines that we're speaking about, and I will introduce you to the UK headline acts. There's thousands of kilometres of existing pipelines within the UKCS. We have major developments in hydrogen, carbon capture and storage planned. Some of the existing pipelines will be suitable for hydrogen transport, as well as carbon and CO2 transport also. This gives us a two-pronged attack at pipelines in general within the Technology Centre, because although we have a significant economic benefit to reusing and repurposing these pipelines, there is also still a keen focus on the infrastructure that needs to be removed. So I'm going to give a quick overview of what that looks like as well within the centre. So sitting within the energy sector, we have multiple tech developers, existing tier one contractors, right down to single personnel companies that are starting up with a new idea, coming through our doors and asking to be supported with new technologies and innovations that they have. So with this, we have a broad spectrum of ideas coming in, but over the past 9 to 12 months, I've in subsequent slides, I've shown some initiatives that people have come to us with on pipeline removal techniques. The current UK market adoption potential is slightly unclear. I'm not sure if that is shared globally. However, there is still an uncertainty of how relevant the repurposing opportunities are within the pipelines network. So at the moment, we are focusing on getting clearer definition within the UK regulator and for a start, for the UKCS, to make sure that the decommissioning of these pipelines is actually going to be a significant focus area going forward in the future. So this is very much a marketing slide, but it shows a vast array of commercialized technologies that we have done to date, having aided the reduction in cost, carbon footprint, increased the efficiency, and harnessed automation, removing personnel from hazardous work sites. I'll cast your eyes to the buoyancy aid here on the left hand side, the coiled buoyancy aids. We will come to them as an example of how to remove pipelines in coming slides. So just a brief overview, very simplistic ways of approaching the decommissioning of pipelines of any size. The first of all isn't actually the removal. It's actually crushing the bundled pipes or pipework in situ, using a heated compression cone on a tracked assembly. It runs along the pipeline and resonates to crush the bundles or the pipelines, and then bury it behind it with high pressure water and or air. This is very dependent on regulator and permissions, but it's certainly something that we are looking at in the UK. It's the one thing to add is the comparative assessment always has to be done on a pipeline by pipeline basis. The second is a self-propelled grab and shear. So this actually leaves the cut sections with plugged ends that can be recovered afterwards, after the shear has been along a section of line. The nice thing about this is the plugged ends are effectively sealed, so any hazardous material is kept, the containment is kept until it is recovered onto the back of a construction vessel. This is a much cruder diagram of the photo that I showed you in technology, the technology being delivered slide. But on your left-hand side here, this is actually a buoyancy lifting concept that the NZTC has funded from inception right through to commercialization, and it has completed its first commercialized job. Effectively, what this is an ambient lifting device that can pull different structures from the seabed in different configurations, in a linear way or in a latitude configuration. It will then be recovered into a casing or framework behind a construction vessel and towed to shore. And then a few full bundle removal solutions. This one in particular is a cutting frame that is self-propelled. It has a pipe grab and a diamond wire saw that cuts sections of around 50 meters of pipe work, and then releasing them into its own recovery frame that is positioned adjacent to the lifting and cutting frame, and then again taken to shore or by deck of vessel. And lastly, an alternative to the full removal is a company, Utility ROV, who has just come to us for funding that has a slightly different alteration of how to remove these bundles and pipelines. It is an all-in-one, all-encompassing ROV operated grab. The concept has been trialed, and the patented grab, it actually manages to bury itself down the sides of any of the bundles or pipelines, to giving a really good clean connection in order to lift it and to cut it in the shear here on the left hand side that you see. All of this is done by a standard construction vessel as well, so very easy to mobilize or demobilize. So to help us along the journey with that was just a few examples of methodologies and approaches that we could take, and they're very applicable globally as well. And really keen to discuss further with anybody that's interested what we're working on in this space. But would really like to introduce the academic partnerships that we have within NZTC. One being the National Decommissioning Centre, a purpose-built centre based again here in Aberdeen, with a partnership between Aberdeen University and ourselves. There has been a £12 million investment in this centre, and it has cutting-edge tools and techniques to help the industry innovate and harvest new ideas, including a new £2.5 million simulator and smart basin that we can offer to the industry as required. We also have a separate partnership with the Robert Gordon's University in Aberdeen with the National Subsea Centre. Very similar arrangement, but this is connecting industry with academic expertise and research projects. And I urge you to look into it a little bit more if there's anything on the subsea side that you maybe want a PhD student, etc., to campaign. So if you want to become a partner of the Net Zero Technology Centre, there's different models where, we have strategic partners, which is effectively a pay-to-play subscription, but we also have program partners and associate partners, who is effectively people in industry that have a problem that needs solved. We can engage the global supply chain and make sure that we can shape the future of the technology and gain access to any of the technology projects that are ongoing in that space. But thanks very much. It's been a very fast introduction and overview of what we've done. I was very conscious of time, so I think I've made up a little bit of time there for you, Daniel.
Yes, brilliant. Really appreciate that. Thanks, Craig, for the very interesting presentation and the interesting toys there that you presented. Let's then move on to the third presentation, and we'll come back for questions at the end. So third presentation has been It's going to be done jointly by Florence Guifontiel, if I pronounce it all right, and Guillaume Delighter. And just introducing quickly, Florence has joined Total Energies in 2009 after 13 years in Vinci Energies Group, contributing to various large industrial and E&P projects. She's now the head of new projects department in Total Energies EP Congo, involved in offshore platform refurbishing and terminal upgrading. She's done worked in different positions in projects in North Sea, in Angola, and integrated the Congo project in 2015 as project manager for the SURF activities. And since last summer, she took on the lead for the entity in charge of project assurance within the technical line of projects of OneTech. And Guillaume is a graduate from École Supérieure des Ingénieurs de Marseille and is working for Total Energies since 2003. Specialized in offshore deep water developments and presently acting as head of subsea and umbilical risers and flow lines department for Project Brownfield for Total Energies EP Angola. He previously worked for Girasol and Rosa projects. Spent some time working on subsea architectures and R&D projects. And between 2013 and 2019, worked on Congo projects, being the construction installation manager in Angola for a few years. So over to you guys.
Yes, thank you, Daniel. So I will try to be quick on the presentation of Cambo Development Project. So Cambo Development is a deep offshore oil development. So the development area is located on Block 32 in Angola, and Total Energy is the operator of this venture. So the water depth of this development is between 1,400 meters to 1,950 meters. On Cambo field, there are 9 reservoirs of Oligocene and Miocene oil. Only 6 of them are currently produced with 2 FPSOs, which are the converted FPSO with straight mooring. So just one thing, Cambo means spice. So it's not a common project that we have to perform. The project FID was taken in 2014. The first of the first FPSO, Cambo North, was in 2018, and the second one in 2019. Just one thing, the project strategy for the SURF activity was to deliver the overall subsea network for both FPSO before the arrival of the first FPSO on site. So just to explain you what is a subsea field schematic for both FPSO. For both FPSO, the subsea configuration are the same. We have 3 hybrid loops of 10 to 12-inch internal diameter with 1 production piping pipeline and 1 service line, both lines in carbon steel. 10 manifolds are connected to the production line. With these 3 hybrid loops, we have 3 water injection lines, 14-inch each of carbon steel, and 1 gas export line, 10-inch in carbon steel also. All these flow lines are connected to the FPSO with STTR risers connected to the turret to 12 flexible jumpers. And in total, 3 main umbilicals connected to FPSO. In terms of line, it's a very large project. if we totalize the two subsea networks of FPSO North and South, we had 300 kilometers of flow line, 120 kilometers of umbilical, 18 risers, almost 100 ELT flats to be installed for this Cambo subsea network. Yes, thank you. For the one word about the Cambo subsea layout, the study was also structured for the definition of the routing and the location of the subsea structure due to several geohazards. So the two main difficulties that we have to manage is the presence of active port marks a lot in vicinity of the structure to be located, and the several instabilities that could be that we have to avoid when the slope of the seabed comes over 5 degrees. So this geohazards have really driven the layout and the routing of the flow. So now I go to our main challenges. The EPC SURF contractor was awarded to a consortium of two main SURF contractors, which are Technique FMC and IREMA. So as you can see on the slide, there are many sites for the design and the fabrication of the subsea structure. In US, and some part of the umbilicals were fabricated at Technique FMC in Houston. And the 100 flat and ELT was fabricated at Schwarzschild in Spain. We have in Europe the fabrication of the flexible in Utrecht, the fabrication of the riser structure, upper and lower structure in Melbourne, UK, and in Lampred Yard, Dubai, we have the buoyancy tank manufacturing. And a big part of the construction were also made in Angola. So the dynamic umbilicals at Angoflats in Angola, we made the development for the single line at Dundee School, and the rigid spool was fabricated at IREMA Yard in Porto Angolo. So there is a lot of sites, and besides these sites, we have also several subcontractors mobilized in Angola for the offshore work. So it was for the survey, the welding, the NDT, and also the pre-commissioning and the ROV services. So it was very, very challenging to manage all these interfaces and to synchronize all the deliveries for the offshore campaign.
Okay, thank you, Florence. So another challenge for Cambo was logistics. So why the logistics was a challenge is because we have a worldwide fabrication area, because we have a large quantity of equipment to be transported, but also because we have a large number of persons to be sent to Angola and then offshore. So how it works from the international fabrication yard, we have organized the transportation of equipment via HLV, dedicated HLV, or via cargo liner. Once arrived in Angola, we have done marshalling activity at different locations in Angola, Porto Amboy, Dende, Luanda, but also Lobito. And after, to transfer the equipment when they are ready to be transferred offshore, we use cargo barge, but also supply vessel. For the transfer of personnel offshore, we use surfer, but also we have done some infield transfer of personnel by surfer remaining at site. So to give some figure, we transported to Angola 95 flat and ILT, so subsea structure for flow line. We transported 18 buoyancy tank. We transported from Angola fabrication yard to offshore 60 spool. But also we have done in terms of logistics over than 55 vessel temporary importation in Angola. Or we have done more than 1,000 more than 10,000 embarking and disembarking manifests for personnel transfer to offshore. So of course, all this was mainly managed by a Technip and RMA or a SURF contractor. So the traversability was also a key challenge because we had to have the good equipment at the good location in good time. Another challenge we have, and it was one of the key, is the fact that we have used the turret FPSO. So the hookup phase was a challenge for us. So we had two FPSO, FPSO Norte and FPSO South. For each FPSO, we have to transfer to FPSO 12 flexible jumper, but also 4 dynamic umbilical that were wet stored before FPSO arrival. The main challenge was for flexible jumper because we have to connect the flexible jumper at the top of the rigid riser. And it was the first diverless connection for a flexible jumper to a top of riser. So the main problem was, and the main challenge is coming from the fact that we have to stroke from bottom to top. So we have developed an intensive qualification program and also an intensive SIT program in order to be sure that all operational when needed offshore. Another challenge we had during the hookup phase, it was to manage the clash between the installation vessel of the flexible jumper on umbilical and the FPSO, because it's a turret FPSO, so the FPSO is turning around the turret. So in order to manage this clash, we had to control the heading of the FPSO by tug. The other challenge for hookup phase was the congested turret we had, because we have up to, it's a big turret with 18 slots. And on the 18 slot, we use 16 slots for flexible jumper and umbilical. So it was congested at the bottom in order to avoid interference, where we installed new riser close to existing one, but it was also congested work at topside to manage the interface between topside work and subsea work in order to avoid standby of surf vessel, but also in order to optimize the first oil date. We had also to perform diving activity in order to secure the flexible riser at the bottom of the eye tube of the FPSO. So among all this challenge, the HSC was the key challenge due to the duration of the campaign. We had a campaign of approximately 3 years between 2016 and 2019. We had at some peak 1,000 persons offshore working for Cambo Surf package. We had up to 5 construction vessels working together at site. We had numerous co-activity to manage. So we had co-activity between surf vessel, we had co-activity between surf vessel and FPSO vessel for the control heading, but also for the mooring of the FPSO. We have co-activity with between surf vessel and also affiliate field support vessel. We had co-activity between surf vessel and seismic activity at field. Of course, also we had some CMOPS activity between surf activity and a live pipeline, because we have to connect the gas export line of Cambo to a live gas export for another block. Also, several critical offshore lifts we have to face on Cambo. For example, we have done 18 double lift in order to transfer from horizontal to vertical buoyancy tank for the riser. As I said, diving operation at congested turret below FPSO, it was also an HSC challenge. And at the end, as we have several times, several same type of riser, we had to face repetitive operation and to fight against routine work. So just to give some figure of what was the marine spread during the offshore campaign of Kaombo. So of course we had the two contractors, Technip FMC and RMA, working as a consortium. So we have for Technip FMC 5 construction vessels. So Deep Blue for pipe-lay vessel, relay method, up to 240 kilometers of pipeline, more than 200 days of operation. Scandi Africa was a very well-efficient vessel at site. It's a multi-purpose vessel working on installation of subsea pile, spool, well jumper, manifold, flexible spool, and umbilical. The Scandi Africa was the main vessel for the hookup phase. Almost 500 days of operation for Scandi Africa. The North Atlantic was also another MSV vessel working at site for Technip. So we had 14 piles to install with the North Sea Atlantic, 6 manifold, umbilical, and well jumper. Also, the North Sea Atlantic was helping Deep Blue for initiation transfer of suction pipe for initiation of pipeline by Deep Blue. Technip used 2 LCV on site. So we had the Bourbon Evolution Ecto 3 and Bourbon Evolution Ecto 5. It was for installation of fly structure, but also flying leads, perform survey, pre-commissioning, and subsea tying. For Bourbon Ecto 3, almost 300 days of operation, and for Bourbon Ecto 5, almost 200 days of operation. Also, as I said, we had the diving activity. So we use PSV and we transform it in a diving vessel. So the diving work was required for FPSO Norte and FPSO Sul hookup, almost 150 days of operation. For RMA, the main vessel was the offshore construction vessel Balder. So we installed 18 riser suction pile with the Balder, 18 single top tension riser, and 15 big piping pipe, 12 in 18-inch, and we use the gilet method. The Balder was offshore for more than 300 days. All this, as I said, it was a key challenge for HSE in order to have a safe operation. And thanks to the commitment of the management since the beginning, we have a successful offshore campaign. Unfortunately, we have only 1 LTI during offshore operation, and it was for maintenance activity. Someone twist his knee during a change of a light. So the success of Kaombo offshore campaign was also the fact that we have to perform almost 1,000 move of installation vessels or rig at site, and we had 0 clash. So as I said, we had work during 3 years, and we had up to 5 construction work at site at the same time. So we use a tool we developed internally within Total Energy called Chemin de Fer. So it was a common tool, but it was very efficient. And we had, thanks to the X-week look ahead planning provided by a SURF contractor, but also thanks to the drilling campaign and the drilling sequence we had from Geoscience and the drilling entity, we managed each week to anticipate the clash for the future and to be able to forecast the clash and to find solution in order to avoid clash. So we were helped in this resolution of clashes by the fact that the field was very spreaded. So we had up to 6 reservoirs. We had the good assistance for SURF contractor to help us to slightly adjust the SURF planning. And we have also a good assistance from rig and Geoscience in order to have some topol at location where we need it. So topol, it's the rig is staying 10 days at a location. So after, when we were at site, we managed the coactivity thanks to the definition of 2 restricted areas. So we have defined a south restricted area for the FPSO south and the north restricted area for the FPSO north. And among this restricted area, all displacement of the vessel from one location to the other was managed by what we call a fiche de liaison, and the authorization to move from one location to the other was given thanks to a marine coordinator. just to show how could be the congested and the traffic and the number of vessels at site, we have just artistic view of what happened on 10 of April 2017 at site, where we had 5 construction vessels from SURF, we had 2 rigs in operation, we have 1 seismic vessel in operation, and also we had 1 field support vessel from the affiliate working at site.
Guillaume, if you could try to finish quickly, the time is over.
Yes, just to summarize, the key contributor for the success, clearly it was a commitment at a high level of the project for accuracy, performance, and means. Also for full cooperation between all the teams, company teams and the concession team. Of course, we have a strong and technical operation skills. And one motto in our project was anticipation and risk management. It was very important to anticipate the risks by having on board from the risk assessment, the key actor of the offshore campaign, like the offshore construction manager. And as you have understood, in a repetitive operation, we have always a first in series, and for that, after each first in series, we have integrated the lesson learned for the next one. And in a so very long campaign and so challenging for the installation, the team spirit mindset was also paramount to achieve this great job. So the next challenge in deep offshore after Karambo, it's our focus on the installation with extreme geohazard and harsh environment. We have more and more on our existing boat the possibility to have a long subsea tie-up, and for that we need a specific pipeline to fight against the hydrate formation. We are also confident to develop a simplified subsea architecture based on a single production line solution that we call MADA. It means that we are confident to have some new approach design against hydrates. So in some conditions, it is possible to adapt the protection of the flow line by having the fluid working in a certain condition to outside the air of hydrate formation. And we also work on the different type of new type of pipe resistant to CO2 or H2S with internal Sierra pipe. And as we have some field with high pressure reservoir, we need also to progress in the 20 subsea equipment, fabrication, qualification, and installation.
Thank you, Florence. I think you are done now. We are a bit over time here. So thank you very much, Guillaume and Florence, for the presentations. I have a few questions. I'll try to do at least one question for each presentation. Just we only have 2 minutes, but let's try to go quickly. So Fabio, titanium is vulnerable to embrittlement caused by hydrogen as a result of CP, cathodic protection. Do you have CP on the titanium transition pieces or the pulling pieces, and how do you deal about that?
Okay, yes, I answer in the chat that yes, we have the CP system of the FPSO, and yes, the titanium is susceptible with embrittlement due to hydrogen from the CP system. It's for this that we use the coating only, but we have the material qualification for this coating, specifying both the material test and also the full scale and also other wear tests specifically for this situation, the pulling system. and also some electrical isolation on the top, and then the studs. So we have several safeguards for this mean of failure also.
Thank you very much. So just rushing here to Craig. Craig, which of the different methods that you show are field proven or at least close to be there, or at least by analogy proven? I was curious about that.
They've all been used now in commercial environments. So I wouldn't be one to judge. I have to stay on the fence with it all, but they all worked very well, and the added benefits to the end user in all guises. So they have now all been commercialized. Brilliant,
thank you. And just to close very quickly, Guillaume and Florence, I see from your presentation the multiple difficulties in logistics and the multiple congested areas and vessels and subsea activities and the turret connections. What was the most difficult aspect of the turret bottom connection there? If you could quickly mention that before we close the session.
Yes, at the bottom, the point is that the fact that when we advance in the pulling sequence, we had to see all the already installed flexible jumper on umbilical, and we have to avoid clash and to avoid interference. So we had this aspect, and after, one of the challenge was as we were pulling without let's say having a diver in order to be sure, because we have a semi-automatic latching system for the bend stiffener to the bottom of the eye tube, and so we have used a subsea camera. So it was quite of stress in order to be sure that our subsea camera is working well up to the end. But it worked well, so we managed to have a successful offshore campaign. Yeah.
Brilliant. Guys, I would love to keep the discussion. It's really interesting, but I've been told to close the session because we are already 2 minutes over. I really appreciate the participation of all of you. Really appreciate the time, the effort you put to present in a conference such very good and very deep presentations. I really appreciate all the audience for the questions. And thank you all very much. Let's move on to the next session in our conference. Thank you.